Hi, I'm Subhalingam, and in the next 6 to 7 videos, I will be talking about this chapter called Haloalkanes and Haloarenes, that is the chapter 10 in chemistry textbook of CBSE class 12. So in this video, let's start with the basic concepts, that is classification, nomenclature, and the nature of the carbon halogen bond. So let's get started. First of all, let's see what an haloalkane or haloarene is. Let's take a hydrocarbon, aliphatic or aromatic anything, and we substitute the hydrogen with a halogen. Then the resulting molecule is a haloalkane if we have taken an aliphatic hydrocarbon, or an haloarene if we have started with a arylic compound. So let's see some examples. We have methane. I remove an hydrogen and replace it with chlorine. So the thing on my right is an example of haloalkane. Now I take benzene. I replace one hydrogen atom with a halogen, again chlorine. Okay, let's take bromine in this case. So the thing on my right is a haloarene. Next, let's try to classify the wide variety of compounds we have. So we are going to classify it on a basis of number of halogens it has. We call it mono if it has only one halogen, and within mono we have further classifications that is based on the hybridization of the carbon to which the halogen is attached. The carbon can be sp3 hybridized or sp2 hybridized. We will look into this in great detail in the coming slides. If the compound has two halogens, we call it di. And again we have further classifications called geminal and vicinal based on the position of the halogen atom. And finally poly if it has three or more. So again, on the basis of number of halogens, we can classify an haloalkane or a haloarene as mono haloalkane or di or poly. So this is an example of mono haloalkane. This is a mono haloarene. Now we add two halogen atoms to an alkane and we get a dihaloalkane, and similarly a trihaloalkane. We can construct or draw dihaloarenes and trihaloarenes and so on. But let's move on for now. Let's try to classify a mono haloalkane based on the hybridization of the carbon to which the halogen is attached. Let's start with the case of sp3 carbon. And one such thing that comes under this classification is an alkyl halide. So in alkyl halides, the halogen atom is bonded to an alkyl group, and we have the general formula in such a case as CnH2n plus 1 X. Further, we can classify this alkyl halides as primary, secondary or tertiary according to the nature of carbon to which a halogen is attached. So here we have a primary haloalkane. We call it primary because the carbon to which the halogen is attached to a alkyl group and two hydrogen atoms. If we look at secondary haloalkane, we see that the carbon to which a halogen is attached to two, two alkyl groups and one hydrogen. Similarly, in tertiary haloalkanes, we have that carbon attached to three different or maybe same alkyl groups, but there are no hydrogens. Next, we have allylic halides. In allylic halides, the halogen atom is bonded to an sp3 hybridized carbon, but the carbon atom next to this carbon is sp2 hybridized. So we look into this compound, we have CH2X at the bottom tip. This carbon is sp3 hybridized and is attached to a carbon that is sp2 hybridized and is doubly bonded to another carbon. Another example, we have X attached to a sp3 hybridized carbon, and if we go right, we have a sp2 hybridized carbon that is doubly bonded to another carbon. So such compounds we call it Allelic Halides. Next, we have something called benzylic halides, where the halogen atom is attached to an sp3 hybridized carbon again, but this time the neighbor of this carbon is an aromatic ring. Let's take this example. The halogen X is attached to CH2, that is sp3 hybridized, and one of the neighbor of this carbon is an benzene ring, that is an aromatic ring. So we call this benzylic halides. In the previous three examples, we noticed that halogen is attached to a sp3 hybridized carbon. It can also be attached to an sp2 hybridized carbon, and vinylic halides are an example of that. So in vinylic halides, we have the halogen atom attached to an sp2 hybridized carbon, and this carbon is doubly bonded to the neighboring carbon. So we have got an example here. We have an halogen atom at the bottom right, bonded to sp2 hybridized carbon, and that carbon is bonded to another carbon which is not a part of an aromatic ring. We call such compounds vinylic halides. Let's look into another type of compound called aryl halides. So even in this case, the halogen atom is bonded to an sp2 hybridized carbon, but this sp2 hybridized carbon is now a part of an aromatic ring like benzene ring, as we have over here. Even this is an example of aryl halides, where the halogen atom is attached to toluene. Now let's look into di-substituted haloalkanes. This is a small classification where we restrict ourselves to halogens attached either to the same carbon atom, we call it geminal halides like this, or halogen attached to neighboring carbon atoms or adjacent carbon atoms like this. We can further classify this and the list will go on. Let's restrict ourselves in this case. So now we have completed our classification of haloalkanes and haloarenes. Let's look at the nomenclature, that is how we are going to name these compounds. As we all know that everything has a common name and an IUPAC name. Let's look at both of them. The common names of alkyl halides are derived by naming the alkyl group followed by halide. Pretty simple. But in IUPAC nomenclature, we name the haloalkanes as a halo-substituted hydrocarbons. Let's take an example. We have CH3, CH2, CH2Br, and the common name we give to this is N-propyl bromide. Let's look into the important IUPAC naming. We start numbering from right because we have Br attached to it, and we go from right to left as 1, 2, 3. Since there are 3 carbon atoms in the main chain, we say it as prop, and hence we have the name 1-bromopropane. Let's look into another example which has branching. The common name we give to this is isobutyl bromide because we have 4 carbon atoms totally, and the iso signifies a branch in the second carbon atom. So the main chain has just 3 carbon atoms. Let's start numbering again. We can start from right because we have the bromine that is more important to us. So starting from right, we have 1, 2, 3 to the left most carbon, and the branching of methyl group is at the second carbon. So we have the name 1 bromo 2 methyl propane. Bromo comes first because B comes first. Next, this let's look into IUPAC name of this compound. Start from right again because we have chloro that is more significant to us, and we have 1, 2, that is the middle carbon as 2, and we can go in any direction, top, left or bottom. Let's go to the left. So we have 1, 2, 3 and 2 methyl groups at the second carbon. So we name this as 1 chloro 2 dimethyl propane. So in this slide we looked on how to name a haloalkane. Let's see how to name an haloarene. Haloarenes are the common as well as IUPAC names of allyl halides. But in common name nomenclature, we use ortho, meta, para to depict 1, 2 substitution or 1, 3 substitution or 1, 4 substitution respectively. Let's look into an example. Things will get more clear. A simple example, we have bromine substituted to one hydrogen of benzene, and we say it bromobenzene. That's a common name as well. Let's look into di-substituted halogen atom. So we have a benzene ring that and a bromine substituted at two opposite carbon atoms. So since it is 1, 4 substituted, we say it as para dibromobenzene in a common name nomenclature. But in IUPAC, we respect numbers and say it as 1, 4 dibromobenzene. And we have this twice substituted benzene in common name, like a layman terms, we say it's symmetric tribromobenzene because the substitution is symmetric. But in IUPAC nomenclature, we say it as 1, 3, 5 tribromobenzene. So before moving on to the next concept, let's try to name more compounds. Let's have these compounds. Feel free to pause the video if you want to try it for yourself. So the first example, in the previous classes we have learned that a double bond is more significant or more prioritized than a substituted halogen atom. So we start the numbering from the left this time. So 1, 2, 3, and there are 3 carbon atoms in the main chain, and the bromo is attached to third carbon atom this time. So we get the name 3 bromopropene. You can also say it as 3 bromopropene. There's nothing wrong in that, but that one is not required. Let's look into CHCl3. This is an important compound and it's pretty simple to name. Name is trichloromethane. Next we have benzyl chloride. In this example, the main chain is a single carbon atom and it does not include the aromatic ring. In fact, the aromatic ring is substituted to a single carbon atom. So we have the name, or let's look at the numbering, that is trivial one, and we name it as chlorophenyl methane, or you can also say it as 1 chloro 1 phenyl methane, but the 1 is not required because there is no confusion even if you drop the 1. A pretty more complicated compound. Let's try to name this. So again, double bond is more preferred, and we start the numbering like this. The main chain should have the double bond. So even though we have a CH3 on the top and we can go to the left, we start with the left because we need to include the double bond in our main chain. So 1, 2, 3, 4, we can see it on the screen, and 3 bromo 2 methyl but 1 ene. If you can number the carbon atoms correctly, then naming is a piece of cake. Okay, let's move on. Okay, we have an exercise over here. This time, let's draw the structure of 1-chloro-4-ethyl cyclohexane. Feel free to pause the video if you want, but I am moving on. So we have 1-chloro and 4-ethyl with a cyclohexane. Another example, let's try to draw 1-bromo-4-sec-butyl 2-methyl benzene. By the way, sec, primary, tertiary, those things are part of IUPAC nomenclature also. But iso, neo, those things doesn't come under IUPAC. Let's continue. Let's try to draw this. We have methyl benzene, 2-methyl benzene. So the benzene is the main ring over here, and we have 1-bromo benzene, 1-bromo, 4 secondary butyl, and 2-methyl. I hope it's clear now, and yeah, I'm moving on. Next exercise, let's try to draw the structures of all the 8 structural isomers that have the molecular formula C5H11Br. Try to name each of them, of course in IUPAC nomenclature, and classify them as primary, secondary, or tertiary. We have learned the structural isomers in the 11th class, so I think it's not difficult except the naming part. So I am telling the answer for now, but please try to work it out yourself. So we have 4 isomers over here and 4 more. Okay, let's move on to the nature of carbon halogen bond, in short CX bond. And I hope by now you could have understood what I mean by X. X is an halogen, it can be fluorine, chlorine, bromine, or iodine. So halogen atoms are more electronegative than carbon. We have learned this in periodic classification or chemical bonding. And because of this, the CX bond is polarized. So the carbon atom has a partial positive charge and the halogen atom has a partial negative charge. So this is all with what happens in a CX bond. Let's look into the trend of CX bond length. We know that the size of an halogen atom increases as we go down the group in a periodic table. Fluorine atom is the smallest and iodine is the largest among halogens obviously, and hence the CX bond length also increases from CF to CI. And we have a table that is taken from the NCERT textbook, table 10.2. So we observe that as we go down, that is CH3F, CH3Cl, CH3Br, and CH3I, the bond length increases. So why should we study about haloalkanes? Let me give you some daily life applications of haloalkane compounds. And these things are taken from the first page of your NCERT textbook. So this can come up in your exams also, I'm not sure. And so first example we have chloramphenicol, that is an antibiotic produced by soil microorganisms, and it is used for treatment of typhoid fever. Our body produces iodine containing hormone, which you all know is thyroxine, and deficiency of this can cause goiter. The first two are naturally produced halogen containing compounds. Let's look into synthetic ones. The first one is chloroquine, that is used in treatment of malaria. Halothane is an anesthetic during surgery. Certain fully fluorinated compounds are being considered as potential blood substitutes in surgery. So that's all from me in this video. Thank you. Hope it was clear. The next video I will be talking about preparation of this haloalkanes and haloarenes. Bye.